So this project was an augmented reality navigation system for wheelchair users, and it was done in collaboration with the Korean company LBStech, and some representative from LBStech are actually here with us today. I actually got to meet them in person for the first time. Janique made contact last year here at AWE, but I have only been communicating with them remotely, so it was nice to meet in person. So this is the base team. These are the students I'm representing. They will be giving a talk at the XR Accessibility Conference in New York at the end of the month. But since they're not able to attend this year, I'm going to show a little bit of the amazing work that they did in collaboration with LBStech. And this project is unique because it was the first practical project that we've done where we've actually actively worked with an industry company on a problem that was interesting to them and the technology that they provided. So it was a very active collaboration that we're very grateful for. And this, we seek this type of relationship because that's feedback that we received from our advisory committee. So that speaks again to this adaptation for the training program. So a little bit of a background, the University of Rochester, like many campuses in the country and the world really, has some difficulties with navigation with wheelchair users. We're in New York, where we get a lot of snow. That doesn't help. But most importantly, this is a big top-down picture of the main part of the campus. And if you zoom in, you can see that there's a lot of areas that have stairs that are not accessible. And there aren't any commercial software or university tools that support wheelchair navigation on the campus more widely. Now Google Maps has an option for wheelchair accessibility. If any of you have tried it, you can click that. But if we apply that to this scenario of getting from one side of the campus to the other, we can see that it actually brings us right through some stairs that are not navigatable. So there's still missing information, there's space for improvement. So the project goal was to develop an AR app that will allow easier navigation for wheelchair users by suggesting actually accessible routes in the app environment. So one of the key aspects of this project was the data collection of locations and features on campus. And you can see here the top-down view of the campus. You can see some of the key buildings that we targeted for this initial prototype that are listed here, and some of the accessibility features that we wanted to address, which are doors, stairs, elevators, and toilets. So you can see here how the data was collected. This was done using an app developed by LBStech, and you can see that we can use the map to navigate where we are. So we're finding the exact location of the building, and it's using the GPS to be able to tell where we are. You can see kind of a zoomed in version of the quadrangle that you saw on the top and those buildings. We can click on a building and then we can choose what type of feature we're picking data from. We can take pictures with the camera and it will store both the picture so we can show it to users, as well as the location and the type of features that that particular entrance or exit of the building has. So working with LBStech on this that already had this application to collect all that data meant that we didn't have to build that infrastructure from scratch, which was an essential for a project that was a one-semester student project. So the actual app development was done in Unity, and what you see here in blue is the APIs that we were able to use via LBStech to the apps that you saw and to their infrastructure that they provide. The orange is the actual user of these applications, and then the green is what the students developed. This is the actual soul of the application. The students used the AR GPS location and Mapbox libraries to assist in building this application. But basically the workflow is the application starts, it's initialized, it talks to the API to figure out where it is and what it needs. It allows the user to select the building, and then it provides information about that building to the user, so the user can choose an entrance that is accessible to them and that has the features like a ramp or a closer bathroom or any kind of information like that. And that's done routing again to the LBS application API, and then we provide navigation to that specific entrance, and that is being provided to the user as the final outcome. So you can see here, it's a very simple interface where they can choose the building that they want to go, and they're able to see both the map and the building at the same time. And then after choosing the building, which is in this case the Rush Ridge Library, one of the main buildings on campus, they can see the list of entrances and then choose the type of entrance that they want to access with actual pictures of that. Now once that's done is where we go into the augmented reality aspect of it, and now everything that you see here today is done on the phone, but there's no reason why this can be taken and updated to be used with spectacles, which is the ultimate goal for this application. So here you see the instructions, the augmented instructions are being overlaid over the real view of the campus on the map, as well as in the actual view captured by the camera, and you have instructions that are telling you the direction that you go. When you get close to a change in direction, it provides you a visual indication, and you also can see further down and being able to tell what the next step is going to be. And you can see that all in action here, where you're navigating, you're going straight. When you approach the next change, it tells you the direction you need to go into, and then it provides you the next location there, both showing you the map on the bottom to the actual map, as well as overlaid on the real world, augmented over the real world. Now, an aspect of this project that I would like to emphasize is that we really needed the feedback from accessibility experts. So Jerry here that you see is an actual wheelchair users, and they are also an advocate for accessibility. They're a graduate student at the University of Rochester, and they were essential in being able to provide us with the most important feedback that we can never know unless we actually have a user with those needs. And we had a lot of features and assumptions that were initially made that had to be changed based on that feedback over multiple iterations with the user. And that included adding voice feedback, because sometimes the visual feedback was not possible if they have to, especially if they cannot use spectacles, they have to hold the phone. Having a voice feedback was important, as well as time to destination, telling them how long it will take them to get to one of these entrances so they can accommodate that to their schedule if they have to get to a class, as well as adding information when they've reached the destination. And we also work closely with Kristen Love, who is an instructor at the Warner School of Education that also provided us with a lot of valuable feedback. So if you take one thing away from this project, is that working with the actual user and having a close feedback loop with them is essential, because you always be making assumptions until it's actually tested in practice. So to wrap this up, the lessons that we learned towards establishing best practices for training AR/VR specialists, I try to summarize them as succinctly as possible. So the key takeaways are: there's a need for a specialized AR/VR multidisciplinary training in academia that can provide the talent that you can hire in the future. There's a dedicated physical space for collaboration, training, and access to software and hardware can be a game changer. And we're fortunate to have that at the university. Theory is important, but there's no substitute for practice, and you will always be able to capture the imagination of people by just putting them to work on things. I work on the engineering side, on the hardware, and sometimes I forget to just use an AR/VR device, and I need to do that to remind myself why we're doing everything that we're doing, because it's cool. And you can't get that unless you actually have hands-on experience. So having the students work on application in practice has been essential. Independent evaluation and adaptation to that evaluation, both from the feedback from the students as well as from the industry, is key, especially in a fast-changing field like AR/VR. And industry involvement is also critical for identifying what are the needs that the students that graduate will need to satisfy for them to be employable from those companies, as well as for providing funding for long-term sustainability. And you can probably tell that I was running out of ways to say essential by the end of this slide. So I would like to thank you today for attending, as well as thank NSF for the funding for the initial program, the University of Rochester for their continuing support for the research in AR/VR and training AR/VR engineers, especially in the new center that I mentioned was being funded. All the NFD program faculty, there's a lot of people here behind the scenes that I'm not mentioning that have been essential in these 5-6 years of the program. Dr. Shedden has been the key lead on this effort, and Caitlin has been the staff member that has been the glue of making sure anything ever happens as part of the program. And of course, I would like to thank LBStech, Studio X, and specifically Megan Moody, as well as the independent evaluator from Compass Evaluation, and our advisor from the Office of Educational Effectiveness, who is also key in helping us target this education problem. So that's everything I have for you.